In this video, we are going to talk about disjoint set data structure, as known as union find data structure. It's a data structure that tracks a set of elements partitioned into a number of disjoint subsets. It provides near constant time operations to do multiple things, and one of the most important things is determine whether elements are in the same set. There are two very important operations for this data structure, which is union and find. And we want to first talk about find. So what does find do? Find returns an identifier of a set, and the identifier is also an element in the set. We just pick that element to be the representative of the set. Let's say if we have a set 1 to 3, and we pick this element to be the identifier, and then we can imagine there's a graph with this identifier as the root and all the other elements as the leaves, like this. And when you ask for the root of the tree, you can call this find function. If you give node 2 to find, it will return node 1 to you, and the same for node 3. And this is how it works. And this tree might not only have one level, it can have multiple levels. So if it looks like this, if input 4 into find, it will still return number 1 because it's the identifier of the entire tree. So this is how find works. And how should we implement it? We can use a map. And map the element with its immediate leader. So here we say 2 is a leader of 4 and 5. 4 and 5 are followers of 2. They follow what 2 does, and 2 follows what 1 does. So 4 and 5 also follow what 1 does. However, in the map, 5 and 4 are not mapped to 1, but you can easily find 1 as the real leader of 4 and 5. This is how it looks like in the map. So 1 is mapped to 1 because it follows its own heart, and 2 follows 1, 3 follows 1, 4 follows 2, 5 follows 2. So each time you want to find a secondary elements in the set, you first get its immediate leader, and then get its immediate leader's leader, and go to the outmost leader, and it realizes, oh, I'm the leader of myself. So then you output 1 because it is the outmost leader. This is how it works for find. And for union is we want to merge 2 sets together. You can also think it as merge 2 graphs. So if we have this graph and another graph, like this, maybe not here, like this, we want to merge these 2 graphs. We can just make a pointer from the head of one graph to the other graph and connect them together. So it becomes this. So 1 just gives itself a new leader to follow. Then everything that follows 1 will follow the new leader, which is 8 in this case. So it's very simple. And this is all one time. You just need to change one thing. Reassign the value that maps to 1. And we're done with this. However, the thing is, if you want to, after you merge this 2 sets, after merged, And then we want to find the outermost leader of let's say 2. Who's the outermost leader of 2? Then you have to go to 1 first and then go to 8. That's too complicated because you need multiple steps. However, if after you have checked for 2, you set 2's leader to 8, because it's the same. 2 is following 1 and 1 is following 8. It's the same as 2 is following 8. So we can just remove this subtree here. So this is the current graph. And we remove this subtree here and put it directly under 8. So next time when you ask for 2, it's gonna be only one step and you will find who's your real leader.